Hi guys. Okay, let's give them the others 2 to 3 minutes so that they can join, and then we can start. In the meantime, is there anyone who have a question on something maybe we did before? Or something else, even if it's not related on what we are doing. Okay, guys, let us start. I gave you homework yesterday. It seemed as if we're still struggling when it came to actually converting these rational numbers to fractions. We'll try and do them as slow as possible. If you have a question and there's something that you don't understand, you can always unmute yourself and you can say what is on your mind. Some are still joining. Let's give them time. Maybe 1 minute or two. I think we are in a position to start now. I gave you these questions yesterday, and I said let us try and write these decimals. And these decimals are actually unique. They are different from the other decimals that we're actually converting, because these decimals are rational numbers. In other words, they have repeating, non-terminating numbers after the decimal point there. So what we are actually going to do here, first let's recognize that 0.4 with a bar is the same as 0.4444, and then you continue writing these 4 and you don't stop. In other words, you just write these 3 dots to say that I'm gonna write all the 4s. And then the next thing that we also have to recognize here is that this number is the same as 0.2222, and then you continue all the way. And then this one is the same as 0.123, 123, 123, and then it continues in that particular fashion. Of course, we place 3 dots at the end. And then this one is the same as 10.8. Take note here that here we had we actually had 4, and we have a bar on 4, which means we are repeating the 4. Here we have a 2, which means we are repeating a 2. And then here we had a bar on 1, 2, 3, which means we keep repeating everything that is inside this bar, which is 1, 2, 3, 1, 2, 3, 1, 2, 3, and so forth. And then here we have a bar on only 7, so 8 is not repeated there. It's only 7 that keeps repeating until you decide to stop somewhere. But you have these 3 dots to say that you continue writing all these 7s. And then the same thing here, we are having 0.124, and the bar is only on 4, which means we will keep repeating the 4 throughout. So it is the 4 that we are actually repeating. But the question was not saying write this like this. It was saying we want to write this number here as a fraction. In other words, we want it to actually have a numerator and a denominator. That is what we want to actually achieve with this. And of course, when we're doing these exercises yesterday, I noticed that some of us actually managed to achieve this one here, managed to achieve this one here, and of course they understood this. And then when it comes to here, we can see that the electricity went off. Some of us did not know what to do. Some of us really tried. There was only a few mistakes, and others, of course, yes, I think is bad. It's normal. It's actually normal when it comes to this. And also another thing here, I noticed that we're still struggling to log in. Some of us are still struggling to join. If you are really struggling to join here, this is what you need to make sure of, that you talk to the ICT. They're supposed to help you. I don't know now that we have closed the campus, but there is supposed to be this is supposed to be easy for us to actually join. Another thing that is much more important here, if you look at how you log in here, I can see that students are struggling to actually see my screen. I'm also using a cell phone to log in, to actually join here. And everything is clear on my side. I don't know why some students are still struggling. I really don't know why they are struggling. But of course, I will record this lesson and then I will upload it after today's lesson. As you can see, I'm actually recording up here. So let's just proceed because we don't have enough. We don't have the whole day, of course. Some of us have other things to do. Let's have our solutions here. I will try and be slow as possible. If there is something you don't understand, you can always stop me. Or if you need clarity on something, you can always unmute yourself and ask the question if you have a question. You don't have to be worried about what other students are going to say. Even themselves, they might be struggling with the question you have. Just ask the question that you might be having. And you don't also have to worry about it. I will get paid for teaching you, so you don't have to worry about it. There's money waiting for me. So here, the first question was we wanted to actually end up dealing with 0 point. It was 0.4 with a bar. In other words, we're actually having 0.4444 throughout. So what you actually do to convert this, the first thing that you do, you just let your x for Dr. Kandi, so you let your x equal to 0.4444, and then you place your dots there to actually say that you are continuing in that particular fashion. And then the second thing that you need to do, you want to multiply this x by a 10 first and see what you're actually having. So multiplying this x by 10, you are multiplying 0.444 and then some dots, and you're multiplying it by a 10. What does that actually mean? It actually means that you are moving this decimal point by how many units or how many times. I have only 1 0 here. So when you're actually having a 1 0 here, it means you want to move this decimal point only once, because there is 1 0 there. So this is actually saying that we are having 10x is equal to, I'm going to move this once, so we'll end up having 4.4444, and then we have some dots there. That is what we are actually getting here. The next thing that you want to do here, you want to check the numbers after this decimal point here. If you look at this number, we have 4444 throughout, so we'll continue writing fours, and then you check this x after this decimal point here. Is this number the same as the number after the decimal point? That is what you are checking. So here I have 444 throughout, and also here after this decimal point we have 444. If this number is the same as that number, then you will take this 10x as it is. You have your 10x, and then you separate this x here, and of course just one x is just this x sitting alone. It means there is a nice one sitting there, and then after that you know that 10x is the same as that, which is 4.4444, and then you continue writing these things, and then you subtract 0.4444, and then you continue to write those things. Of course, if you have a 10 x's and then you decide to delete one of your x's, you don't want him or her to actually appear in your timeline. You decide, okay, I'm gonna remove one. You will be left with 9 x's. You get what I mean? And then of course, at this side, you know how to subtract decimal. You first write the first decimal number as it is, and then after that you write this decimal number part. Before you write it, you look at this decimal point, you make sure that it is in the same line as that decimal point there, and then the next thing that you actually do, you start with this number and you write it here, and then you make sure it is aligned with the first number, and then you continue to write all these numbers in this particular fashion. And then of course, when you look at the numbers before the decimal, you start writing them from here, and then you make sure that it is aligned with that number, and then you continue to write the rest. Of course, we are subtracting here. That is actually what we are doing. 4 minus 4, that is 0. 4 minus 4, that's a 0. 4 minus 4 is a 0. 4 minus 4 is a 0. And then we have that dot there. 4 minus 0, we know that is just going to be 4. And we will continue to have zeros here. That is actually what we are having. And 4.0000 is just the same as a 4 here. In other words, we have removed these numbers after the decimal point. That is why we wanted to make sure that these numbers that are after the decimal point are the same before we can subtract these two things. So that is the main goal here. And then after that, you have your 9x and you have a 4 that side. And if you're actually having that, you will find out that we need to divide on both sides by this 9 here. You divide by this 9 there. And of course, this 9 and that 9 will cancel out. And now you are left with one of your x's becoming equal to 4 over a 9. So that is how you actually end up understanding this whole thing. Guess what usually happens here? By just saying that I'm going to let my x to be equal to that, you get a nice mark there, and then you multiply 10x by x by 10, you will get another mark there, and then you subtract this thing here, you will also get another mark for subtracting this whole thing. And of course, your 2 marks are waiting for the final answer. That's how the marking is actually happening when it comes to these things. You get full marks, and then you are actually good, and you are free to go to your graduation after this thing. Remember that at this stage we are on NQF level 5, if I'm not mistaken. I'm not sure if I actually think that we are on NQF level 5. So the aim of this is to make sure that we graduate in record time, and also not only that, we want to make sure that most of us are actually graduating with a good average. So things that are easy like this, make sure that you are getting more marks so that you will have a good average, just in case you decide to change your mind and then you decide that you will go to a postgraduate level and you continue to do your advanced diploma, and then from there you go to your postgraduate diploma or honors, and then to your masters, so that at least you qualify. That is what is important. Make sure that you pass. That thing of getting a 50, guys, is only a trap for you. Try and avoid getting 50s and make sure that you're getting above 8 if possible, so that you will be able to get funding when you're applying for funding and scholarships and also bursaries that are out there. Let's look at number B. Our number B, let me use a black here. Our number B was actually 0.2 bar, which is the same as 0.2222, and then you have 3 dots there. So your solution is just very simple here, because all you need to do, you just need to let your x to be this. So we're having 0.2222, and then after that, of course, you wanted to multiply this thing by a 10, and then you have a 10x, and then after that, once you multiply by 10, of course, you will have 0.2222, and then you have those dots. You are multiplying that by a 10, and of course this one is still 10x, but this side you are moving this to this side here by how many times? It depends on how many zeros you are having here. We have 1 0 here, so we are going to move it here, so we'll end up having 2.2222, and then we have the 3 dots there. Once you have that, the next thing that you need to do, you need to check the number after the decimal point here. You can see that the decimal point is there, and this is the number after the decimal point, and you want to check, is it the same as that? So you can see that it is the same, which means we can subtract this one with that one, so that the numbers after the decimal point can be removed. So the next thing that we'll do, we'll just take 10x minus x. Of course, if you have this x here sitting alone, it means there is a 1 there, and then after that you just say, okay, 10x was the same as 2.2222, and then you subtract this number here, which is 0.2222, and then you have your 3 dots. And you have 10 of these things here, and you have 1 of these things here. So what you need to do now, you just need to remove 1. So if I take out 1 out of 10, I will be left with 9 of these things here. And then this side here, here we are having 2.2222 and have 3 dots, and then we wanted to subtract this decimal here. When you want to write this decimal, you place a dot there, and then you just write a 2 and a 2 and a 2 and a 2, starting with this 2 after the decimal, and this decimal point, want to make sure it is aligned with that decimal. And then this number here, we start writing from here, so we have a 0 there, and then of course we have the 3 dots. 2 minus 2, that's a 0. 2 minus 2 is a 0. 2 minus 2 is a 0. 2 minus 2 is a 0. We have a decimal point here. And then 2 minus 0 is just a 2. Of course, we have the 3 dots there because the same thing that was happening here will have a bunch of zeros throughout. And 2.00000 is the same as just a 2 here. And then the next thing here, since you are having 9x is equal to 2, you divide by this 9, the number that is in front of this x, on both sides. And of course, your x is just going to be a 2 over a 9. And then once you are there, just know that at least you have some mark there, you have some mark there, you have some mark there, and you have your 2 marks there. And if it happens that you made a mistake somewhere, you don't know what is the final answer here, you end up losing this mark and 1 mark goes there. But at least you will be getting something if this is a long answer question. Hope you can get what is happening here. And also another thing that we usually do, if this one here is not in its simplest form, then you lose only 1 mark because we want it written in a final simplest form. And then we had our C, and then our C was very nice. We had 0.123. And then of course here we had 1 bar, which means that we're having 0.123, 123, 123, 123, and then we continue in that particular fashion. So the only thing that you need to do here to find this, to rewrite this as a fraction, all you need to do, you just need to say let x equal to 0.123, 123, 123, 123, and then have some dots there, and these dots here are supposed to be 3. We have 1, 2, 3, not 4 or 5. So we're having these nice things here. And then of course, for you understanding that you are being taught by Dr. X here, so we'll have this X here, you have a mark. Think about it. There is a mark that is waiting for you for realizing who is actually teaching you this maths here. And then the next thing that you wanted to do here, you wanted to multiply this nice thing here by a 10. So we are going to multiply this by a 10, so we'll end up multiplying x by a 10. And then of course, once you multiply by a 10, you take this dot here, right? So we are having this dot here, and we are moving it once, so we'll move it to this point here, so we'll end up having 1.23, and then we'll end up having 1, 2, 3, 1, 2, 3, and then 1, 2, 3, excuse me. So we are having this nice thing here. But now another thing that I want you to actually realize here is that this number here, this number that is here, I want you to take a look into this number here. So if you look into this number and that number there, they are not the same. Here we are starting with a 1, here we are starting with a 2. So I cannot use this one and that one because the number after the decimal point are different. So the next thing that I want to do, I multiply x by 100. to actually see what is actually going to happen. So if I'm multiplying x by 100, what am I getting? It means that remember that I'm still multiplying this thing now by 100. So if I'm multiplying this thing by 100, I want to move this decimal point how many times? 2 times, because I have 2 zeros there. I want to move it from here to there and there. So we're going to end up here. So we'll end up having 12 point, because now it moved 1 2, it was here. So we end up having 3 here, and then we have 1 2 3, and then we have 1 2 3, and then we have 1 2 3, and so forth. But if you look into this number here after the decimal point, it is not the same as this number, so I cannot use this one and that one. At the same time, if you look into this number here after the decimal point, it's not the same as that one, so I cannot use this one and that one. So we try and multiply by 1,000. So we just put 3 zeros and we have an x there, and then now this decimal point, we're moving from here to 1 2 3, so it's going to be there. So we'll end up having 1 2 3, because we're moving it 1 2 3 because we have 3 zeros there. So we'll end up having 1 2 3, and then we have a dot there because it moved from here 1 2 3, and then after that we have because we're going to start here, so we'll end up having 1 2 3 1 2 3 1 2 3, and we continue in that particular fashion. And then the next thing that we check now is this number after the decimal point the same as that one. Of course it is not, so we cannot use that. And then is this decimal point, the number after the decimal point, the same as this one? This one starts with a 2, this one starts with a 1, so we cannot use that, of course. And then we look at this number here. Is it the same as that number that is there? And you can see we have 1 2 3 1 2 3 1 2 3 throughout, and also here you have 1 2 3 1 2 3 1 2 3. So this one here is the same as that, so we are going to use this one here and that one. Guess what is going to happen? By realizing that this is what we are going to use, you have another mark there. So the next thing that you actually do, you want to take your 1000x and then you subtract this 1x there, right? And then after that, of course, 1000x was the same as 123.123 123 123, and then we continued, and then we are subtracting 0.123 123 123, and then we continue all the way up. And then the next thing here, what happens when you have 1000 things and you are taking one out? You have a calculator here. The calculator can assist you with that, but of course taking 1000 out, I'm subtracting a 1 here. I can do that, and then I'm subtracting, let me write it here so that I'm not just saying this in words. I have 1000 here and I'm subtracting 1, so 1 is supposed to be there. And then of course 1000 is the same as 1000, 0, and then 1 is the same as 1 0. Then in order to write this decimal point must be aligned with that decimal point, and then we have a 0 this side and we have a 1 there. That is why we start here and we go all the way. And of course we are subtracting here. I can even remove this because it's not necessary. I was just trying to show you. So 1 minus 0, we can't do that, so this one goes and borrow here, and then there's nothing to borrow, and then this one goes there, and then there's nothing to borrow, this one goes there, and of course it borrows this one. Once you take the 1 out, you will be left with a 0 here, and then this one will come here. But this one, we're not subtracting from it, we're borrowing, so we're going to take 1 out of 10 here, so we'll be left with a 9 here. And then here we place the 1, and then out of this 10 we're not subtracting from it, we're borrowing, so we take this one out and then we give it to this one which was borrowing. When we're taking this one out, here we had a 9 there, and then 10 minus 1, we know that is a 9. Of course, there is nothing here, which means there is a 0. Nothing here, there is a 0. Nothing here, there is a 0. 9 minus 0, we know that is a 9. 9 minus 0, we know that is a 9. 0 minus 0 is just a 0. So here we are going to end up having 9x is equal to, or you can just use your calculator and say you have a 1000 minus a 1, which is just 999. And then this side, we are actually having 123.123.123. So 1 to subtract, we had 123.123.123, and then we have the dots. But we are subtracting this one here. So this decimal point, we want it to be here. So it must be aligned with this decimal point there, and then we start writing these numbers. So we start with 1 must be aligned with 1 2 3, and then 1 2 3, and then we continue all the way, and then we start writing these numbers before the decimal point, which is just a 0. There is nothing here, so you just place a bunch of zeros and we are subtracting. What are we going to get? 3 minus 3 is a 0. 2 minus 2 is a 0. 1 minus 1 is a 0. 3 minus 3 is a 0. 2 minus 2 is a 0. 1 minus 1 is a 0. This is just a decimal point. Of course, this one is supposed to be a 0, not a 1. And then we have 3 minus 0, that's a 3. 2 minus 0, that's a 2. 1 minus 0, that is a 1. And of course, this is going to continue forever. We'll have a bunch of zeros. So this is going to be 1, 2, 3. And then, of course, now we are having 9x is equal to 1 2 3, and then we wanted to remove this number here, which is multiplying x. So when you are removing multiplication in front of x, you do it by dividing by that number. So we have 999, but because I'm dividing this side, I also wanted to divide from that side. This one will cancel that, and you'll be left with 1x. And then this side here, you have 1 2 3 over 999. And of course, if you look into this, you can cheat this process by just using your calculator and say you have 1 2 3, and then you divide this by a 999, and then you will get a simplest form that is supposed to be somewhere here. So what will be the simplest form? We cannot use 1, so we try 2, and then if we're trying 2, this one here is an odd number, so we cannot divide by 2 and not leave a remainder, so we try 3. How many 3s out of 12? We have 4. And how many 3s out of 3? We have 1 of them. And then from this side, how many 3s out of 9? We are actually having 3 3s out of 9 and without a remainder. And also here we are having 3 3s, and also here we are actually having 3 3. So we have 3 3 3, and you can even check if is there any common factor that is available here. You try 2 cannot go there, and then you try 3. How many 3s out of 4? We have 1 3, and then the remainder is 1. You place a 1 there, and then after that you can just say this is 11. How many 3s out of 11? Of course, we'll have a remainder. So what we actually do from this stage here, you can try other factors, but you will see that there is no other factor that is more than a 1 that can actually be common between these two. So this is the simplest form. Guess what happens? Because you knew that you can actually go all the way and arrive to this one here, there is something that you're actually getting here. You are getting some mark, and of course here you can get some mark, and then there is some mark there. So you are getting some nice marks here. You can see that you are almost on your way to getting a distinction here, or a cum laude. Who knows? There is a chance. And then the number D, we had number D. Let me try number D. Do you want to try number D by yourself and tell me what you are getting, or do you want us to proceed in this same fashion? If you are not saying anything, I will assume that you want to do it. You can do it, it's fine. Sipo, you want to say something? Sipo, do you want to say something? Don't be worried. You can say what you want to say. Okay. Can you try number D and... okay. Can you try number D and number E and see what you are getting? You can send it on WhatsApp and see if we are getting the same thing. Okay, let me try and load my WhatsApp here. My WhatsApp is a little bit slower. Let me see here. We have number D. Lulu Tojevo, you did something here, which is much more interesting. Okay. Luluto, there's something that I wanted you to notice here. You are on the right track, but 100 minus 10 is not 99. Just fix that. You will see the answer will be correct. 100 minus 10 is it's not 99. Fix that and then see if you are getting the right answer. Only fix that. Let me look at Sapokazi. You are having this one here. The only thing that you're supposed to fix, you're supposed to subtract from 100x, which is correct. You're supposed to subtract 10x instead, not 1x. Supposed to subtract 10x instead, and then you will see your answer is going to be correct. Subtract 10x from 100x, your answer will be correct. Anyone else who have something? Yeah, okay. Luluto, there was only one thing. Everything is fine here. The only thing that you needed to do here is to subtract 10. This is 10, so you're having 10x here. So we have a 10, so 100 minus 10. One thing for sure is not 99. Once you fix that, your answer is going to be correct. Okay. Others are still trying. You can also do number E. And if you can do that, then we'll move to something that is so close to what we wanted to do with this course, which is the most important part of it. As much as this course is all about exposing you to some of the mathematical tools that you will actually need in mathematics. Okay, Luluto, this is correct now because all I wanted was that 90. So it is correct. Try number E. Try number E. The main point of this course, or the main goal, is to make sure that you are exposed to some of the tools that you will need, both in your career and also in the courses that are coming, e.g. statistics. Maybe when you're doing your third year, we will be doing statistics together. If you're not lucky enough, then Avele, your answer is 100% correct. There's nothing to fix there. We have 100, we have 10, and then yeah. Our value answer is 100% correct. Let's try and do number E. Want to see number E, then we can move to something else. And also another thing that is much more important as an accountant, not only accountant, an auditor, you will be dealing with big amounts of money, people's money, and you don't want to make a mistake when it comes to calculating other people's money, whether it's a salary or it's you are actually auditing a business or whatever. You don't want to make a mistake with money because you will be fired. So in this course, we wanted to make sure that at least you are exposed to some of the tools so that you can make mistakes somewhere else, but you don't make mistakes when it comes to people's money, which is the most important thing. In other words, when you're dealing with simple interest, compound interest, and all those things, and you will see that if you want to deal with compound interest, you need a huge understanding of exponents and laws of exponents, and also logarithms. We're not gonna go too deep, but we're just gonna take some of the tools that are so important for you to understand. Of course, as much as we are trying to make sure that you get exposure to so many things, later what you wrote is fine and is correct 100%. Let's try number E. Once we are there, you will find out that we need to have a huge understanding of exponents. That is what is important. Let me look at Lulutojev, what you wrote there. You are actually having this is, I can't see properly. Okay, this is 28 over 225. So you had 1000 and then you subtracted from 1100. Mfethu. Aye. Mele sikuphasise kule course mfethu. I think you already get what is happening here. Mele nje siyakuphasisa nje mfethu. You go to the next level. Because this is what I expected. You just multiply by this 100 and then you get something nice, and then you compare these two, and then this is 1000, so this one and that one is kind of the same. We have 900. Lulutho mfethu masikuphasisa. So we have Lulutho is done with number A, so he gets it, and then Lilita is still trying to connect. Yeah. So I think we are done with this part. Can you send me your answers? I want to see where you made a mistake so that we can move forward and talk about some other things which are very much important. Exponents. Exponents. They are nice. And try and define what is an exponent. Just gonna wait for three more replies. I want to see where you struggling with this, but this is not hard, guys. It's not hard at all. We're not doing anything hard in this course. We're only doing things that are important, unlike when you are doing things in other fields, whereby you have to learn some other things that are not that much useful. We're only focusing on things that you will need here. Just two more and see if you were actually understanding this. Just two more. Just two more, then we can move forward. Let me see. Avele, we have that multiplied, and then you multiply it again, and then you add that. Okay, sure. That's fine. That is fine. How many marks are you getting? Let me check. before you come to my office and say, sir, where's my mark here? I want to check how many marks you are getting. So you have this one here, 1, and then 2 here, and then 3 here, and then 4, 5. Okay, you're getting all the full marks here. And then here you are getting also full marks. Some people wanted to shortcut this thing, and when you're shortcutting it, just know that you're also losing some marks. That's what they usually do. Okay, we're fine. Almost fine. Almost fine. You can see that in D. Let me just try and write my solution here. We're having a 0 point. No, it was not 0 point anything. So we're having this one here. So we have we had 10.87, and then we had a bar there, and we know that this is the same as 10.877777 and so forth. So what you do, you just say let your x equal to this number here, which is 10.877777. So you're having that was supposed to be our D. Is that 100% correct? Let me see. Oh, was our D, of course. So now that we are having this one here, you multiply it by 10x. Of course, when you're multiplying that by 10, you are actually moving this decimal point 1 time. So you move it here. So we'll have 108.7777, and then you have the dots there. And then if you notice this number and that number, they are different, so we cannot use these two things. So we multiply by 100 this x and see what we are getting. So when you're multiplying by 100, you will find out that actually what you are getting here, you are actually getting here we're having 2 zeros, so we'll move this 1 2, so the decimal point will come here. So we'll have 108, and then because we're moving it here, so we'll have a 7 there, and then you have this 7 after. Then you have 3 dots. So that is what is important here. And then if you look between this number after the decimal point, this number and that number is different. So because they are different, we cannot use this one and that. And then you check this number and that number. After the decimal point, we have all the 7s, and then after the decimal, we have all the 7s. So we use this one and that one. Then, of course, once you are having that, which means you will have 100x minus 10x is equal to 1087.7777, and then you have the dots, and then you subtract 108.7777, and then you have the dots there. And then the next thing is you have 100 minus 10. Once you have 100 minus 10, you know that you'll be left with 90x. And then this side here, you are having 1087.7777, then you have the dots there. And then the next thing is you want to align this decimal point with that decimal point, and then you start writing these numbers as they are. We start with 7 here, 7 7 7 7, then you have the dots. And then before that, you start writing these numbers from here and all the way that side. So we have an 8 here, and then we have a 0, and then we have a 1. Of course, if there is nothing, it means there is a 0 and we are subtracting. So we're having 7 minus 0, that's a 0. 7 minus 7 is a 0. 7 minus 7 is a 0. 7 minus 7 is a 0. And we have a decimal point. And 7 minus 8, you can't do that. So if you wanted to subtract here, you need to come and borrow here 1. So here, if we are taking 1 out, you will be left with 7. And then we have this one here. And then you ask yourself, 17 minus 8, you know what is 17 minus 8, that is supposed to be a 9. And then of course you say 7 minus 0, you have a 7. And then of course you have 0 minus 1. You can't do that. So if you wanted to actually do this, what you actually do, you just come and borrow here one thing. When you're borrowing 1 here and take it out, you'll be left with 0, and then you place this one here. And then once you place this one here, you have 1 and this 0, so this is a 10. 10 minus 1, we know that it is a 9. And then 0 minus 0, that's just a 0, and then we just end there. And then we have the dots because we'll end up having so many zeros. So this side, you will have 9, 7, 9. And then of course, we just removed this and subtracted 10, 8, 7 minus that. And then this side here, you end up having this 90x, and then you have 9, 7, 9. And then you divide by 90 this side to remove this 90. You divide that 90 that side. And this and that will cancel out. And you'll be left with the x is equal to 9, 7, 9. And then you divide that by 90. You can check with your calculator here to just say what will be 979 divided by 90. If there is no common factor, it will give you the same thing, so we end there. So that is what is important here. We are done with this one. Let's try number E. Number E is very much interesting. Actually, number E is not that much challenging. Let me double check here. Our number E here was 0.124, and there is a bar at the end. So we had 0.124, there is a bar there, which is the same as 0.12. We're only repeating a 4. So you repeat the 4 as many times, and then you have the 3 dots. So the next thing you do, you just let your x equal to that number there, 0.124444, and then you have the dots. You multiply x by 10, right? And then once you multiply 10 by x, you're moving this once, so we'll have 1.2444. And then you look at this number here. This number is not the same as that, so you continue to multiply by 100 this time. So we move this one here, this decimal point 2 times because you have 2 zeros, 1, 2. So we'll have 12.444. And then you have 3 dots. When you check this number here, it is not the same as that, and it's not the same as that. So you continue to multiply. That's what you do. So you multiply by 1,000 now. In other words, you move the decimal point by 3 times. So you move it 1, 2, 3. So we'll end up having 24 point, because we move it 1, 2, 3, and then we'll have 4, 4, 4, and then we continue having 4s. And if you look between this one, look at this number after the decimal and that number, these numbers are the same. So since these two numbers are the same, you can see that you can actually deal with this one and that one and leave that one out. So we can separate these two. So we can just say 1000x minus 100x must be equal to, I take this number as it is, 124.4444, have some dots, and then you subtract a 12 point, we have 444, and then you have all the nice things that are happening there. And then the next thing is, what is 1000 minus 100? You can see that if you have a 1000 rand, when you are withdrawing it from a bank, you know that you have 10 hundreds. So you will have 100, 100, 100, and 10 of them. So once you take 100 out, you will be left with 900. So here you will have 900x, and then this side, of course, we do the same thing that we like to do, which is using tens and units to subtract this. I have 1, 2, 4, I have 4, I have 4, I have 4, I have 4. And then the next thing here, you want to align this decimal point with that, and then start writing the numbers after the decimal. So you'll have a 4 and a 4 and a 4 and a 4, and you want to make sure these numbers are aligned. And then the next thing you will place, you'll start writing this. So you'll have a 2 there, and then you have a 1. When there's nothing, you always place a 0 and you subtract. Of course, we still have the dots there. There must be 3 dots at the end. Now that we are having these 3 dots, 4 minus 4, we know it is a 0. 4 minus 4 is a 0. 4 minus 4 is a 0. 4 minus 4 is a 0. And then you have a dot there. And then you have 4 minus 2, you know that is supposed to be just a 2. 2 minus 1, you know it is a 1. And then 1 minus 0, it is a 1. So we have 112 here. So we'll have 1, 1, 2. And then, of course, when you're having that, you just know that you have 900x equal to 112, and then you want to remove this, so you divide by a 900, you divide by a 900. So this one and that one will cancel out, and you'll be left with your x equal to 112, and then you divide by a 900. Of course, here there is a highest common factor. We don't know what it is. You can just press this in a calculator and get the answer, or you can just try, because I see a 2 here. I can divide by 2 until I get what I want. How many 2's are contained in 11? We know that we have 2, 4, 6, 8, 10, so we have 5 of them, and then the remainder is a 1. And how many 2's are in 12? You know that there are 6 of them. And then you come here. How many 2's are actually contained in 9? You know that in 9 you have actually 4 2's, and then the remainder is 1, and you place the 1 there, and you ask yourself how many 2's are contained in 100. You'll find out that there are 50 2's there. And this whole thing can actually come down and also ask how many 2's are here. How many 2's in 5? You are actually having one. No. Out of 5 we have 2 4, so you have 2 2's, but the remainder is a 1. So how many 2's in 16? You have an 8 there. And then you go down here, you ask yourself how many 2's are actually contained in 4. Of course, there are 2 of them. And how many 2's are contained in 50? There are 25 of them. So this should be your final answer, or you can just press your calculator. It's going to move you somewhere there. So you have 112, and then you divide that by a 900, not 9,000. So you are having this nice thing here. You get full marks. Any questions so far? Anyone who have a question? You are sorted. Okay, I see. Most of us are sorted. Exponents. I want us to deal with this. Guys, I have a question. Do you want us to proceed with exponents today, or your head is heavy? You want us to continue another time? You can unmute yourself and share your view. Guys, are we still solid? We still have more 30 minutes there. You have you still have some stamina, or should I give you 5 minutes to drink some water and come back? Which is which? Or should I ask our faces to decide for you? I know they are ready to decide for you. Let's decide, guys. What should we do? Should we proceed, or should we Just take it as a day today. Okay, let's move. We still have some time, but I'll give you 4 minutes. Go and drink some water and come back, so that you are ready to learn. I'll give you just 4 minutes. At 1:35, we should be back and proceed. So these are the exercises I would like us to do. Of course, if we don't have time, we will actually take them as a homework. Let us proceed now. I think we actually did get some time off. So try and drink something, because someone is writing something. Who is writing something? 36. Solomzi was still busy with this number E. Number E is fine. You have 112 divided by 900. So we're having 112 divided by a 900. Of course, that's what we do. This is just the same as 28 over 1 2 over 225. So this is correct. Solomzi. Let us now proceed with laws of exponent. This is correct. Just to make sure that you simplify it to you write it in a simplest form, because you can see that is 28 over 225. That's the only thing you need to add, so that you don't end up losing some marks, 1 mark or 0.5 of a mark. Let us talk about what is an exponent, and then we can actually move forward and look at laws of exponents, and then after that we can take some examples. Where am I? This one is your homework. Make sure that you capture it well and you try and solve it. If you can't solve it, then of course you will get some help maybe tomorrow during a third session. But here is the thing that I want us to first talk about. The exponent. What is an exponent? Exponents. So let me write it here as a definition. We don't usually ask definitions when it comes to maths. We are focusing on calculations, but it's important to know the definition. An exponent. What is an exponent? An exponent is a number. Must be a number first. Why am I writing so bad? It is a number, right? That is written. So we write this number as a superscript. It is a superscript to another number. The superscript to another number. This number is usually called the base. So an exponent is a number that is written in a as a superscript to another number called a base. Now, what does an exponent actually tell us? This is one of the things that are actually important. I have to write it down. It tells us how many times the base is to be multiplied by itself. So that is actually by definition what we call an exponent. So let us take an example of what I mean by this. So if let's say I have a 2, and then I write, let's say, maybe a 3 there. You can see that I have a number that is sitting down, and I have something that is somewhere there on the right, but a little bit up. So what we are actually saying here, we have a number here that is sitting here, and then you have another number that is somewhere there on the top right corner of this number. And in this calculator here, you have something like this. You have x raised to something here. It's actually saying that you are having something of this type. So this number here, I'm going to circle it. That's not what I want to do. I want to circle this number here. This one, we call it the base. And then this number here is the one that we actually call it an exponent. So whenever we're writing a number like this, we are actually saying that this one is the one that we call it an exponent, and this one is the one that we call it a base. And the meaning of this thing here is actually telling us that I have 2 to the power, 2 raised to that exponent 3 is the same as 2 times 2 times a 2. That is the meaning of having that number up there, or that exponent. So I hope you can actually get what I'm trying to actually show you here, that an exponent is only that number that is up there. And then the next thing that is usually confused with an exponent is usually called a power. I want to talk about this power here because most people usually confuse an exponent and a power, and they usually say that this one here, this 3, is the same as the power. That is not 100% correct. I don't want you to also be mistaken with this thing here. What is the power? A power actually refers to this whole expression here. So basically, if you look into this one here, let's try and expand it and talk about everything that is actually happening here. So we are having this 2, which is inside this box here, as I explained, and then we have this 3 here, which is inside this box here. And of course, if you are writing this here, you know that it is the same as 2 times 2 times 2 times, no, we have 3 of these 2's. This is actually telling us how many of these 2's. And then 2 times 2 is 8. 8 times 2, we know it is a 16. So I want us to talk about this power. What is a power? We know that this one here is an exponent. This 3 is an exponent. And then this 2 here is the one that we actually call it a base. Then this 16 here is the one that is the results of simplifying this. Of course, this is a multiplication, not decimal point. So this 16 here, which is the results that you get after multiplying this several times, is the one that we actually call it the power. So 16 is the power, right? And also, if you look at 2 and 3 as a whole, because 3 are raised to exponent 3 is 16, so this one also we call it a power. I hope you can see the difference, that the exponent is only that 3 there, the base is only that 2 there, the power is this whole thing here, or this whole expression, or it is just the results there. So this is the power, and also that whole thing is a power. Anyone who's not getting the difference between these can unmute themselves and ask if they have a question. If you don't have a question, you can just press a thumbs up so that we can move forward. Okay, which means we are still good. So I don't want you to actually be confused with the power and the exponent. And I've seen some people who usually say, no, this is this 3 is a power. No, that's not correct. The correct way is to say that the whole results, or this whole thing, is the one that we call it a power. So that is what we are actually saying here. I want us to also mention something else here. We have a nice example here, right? So this example here is saying this one thing. I have 2 questions here. The first one is saying, write the following in the expanded form. That's the first one. And the second thing here is saying and in the standard form. I want you to understand these things here. They are very much important. I'm going to give you what I want you to write here. So I am having an A here. My A is 4 raised to an exponent 2. And then my B here is actually 3 raised to 3 raised to an exponent 4, and then the third one is actually 2 raised to a 4 there. So we wanted to write this 1, 2, 3 in an expanded form and in the standard form. So if let's say you look into this one here, this written in this one is actually written in an exponential form. So once you have a base raised to an exponent, you must know that you are actually having an exponential form. And this thing, of course, it is equal to 4 times 4. So having 4 times 4, you can see that this one, I have expanded this. In other words, I have multiplied 4 by itself 2 times. So we are having this. So this one, we usually call it is written in an expanded. This is expanded form. So this form here is the one that we usually say it is written in an expanded form. And the standard form here, 4 times 4, we know that it is a 16. So this one here, writing it as just one number, this one is the one that we say it is a standard form. So I hope you can see the differences here, that when you have a number raised to an exponent, it's an exponential form. And then when you're having this written this way, we are actually having an expanded form. And then this number here, which is the final answer, it is in the standard form. I hope you can see that. So this one is going to be 3 times 3 times 3 times 3. So this one is an expanded form. This one is an exponential form. And of course here, how many 3's do we have? 1, 2, 3, 4, which means we have that. And then 3 times 3, that's a 9. 9 times 3, that is actually 27. 27 times 3, that is actually supposed to be a 81. So this question here was saying write this like this and write this like that. And then the same thing here, we're writing this one like this. This is an expanded form. And then of course you move from this one to this one, which is an a standard form. This one is an expanded form. This is a standard. The same thing with this one. How many 2's you must have? You must have 4. So we'll have 2 times 2 times 2 times 2, 4 of them. Of course, 2 times 2 is a 4. 4 times 2 is a 8. 8 times 2, that is a 16. So this one here, it is an expanded form, and this one is a standard form. Anyone who's not getting this this thing here, so that we can move forward if we are all in the same same pace? Anyone who's not understanding it so far? If you understand it, okay, sure. We have someone who understands it. At least you have one. The good thing is that if we have 2, they will explain in the group that next for call. But he was trying to say this to me. Yeah, so that's what you can actually see. And then the next thing that I want you to actually know now, we can actually have some few laws, and then we'll take examples, and then you can go to your homework. So we are having laws of exponents. How does exponents actually work? Laws of exponents. So this is not a good handwriting. Let me try and write. So we have what we call laws of exponents. Like I said, I don't want us to end up doing things that are not going to help you with anything. So there are so many laws that are out there. So I want us to only focus on 7, only the 7 laws. And then once you understand these laws, then we'll be able to do other things. There are so many of these laws. Some of them, I don't ever think that you might end up using them anywhere. So let's focus on these 7s that I know that they are very useful, and you have to know them, and you have to know how to apply them. And when I'm speaking about laws of exponents, you might think that there's this big law that was actually approved at Parliament, so everyone needs to obey this. I'm actually talking about how do you end up dealing with multiplication of these powers and division of powers, and how do you take roots of powers, what happens if you have a negative exponent, what actually happens if you're actually having a positive exponent. But before I do that, I also want to show you something here. With this calculator here, I'm not sure if all of us are having the same calculator. I just want to explain some of the things here. So to write this 4 raised to an exponent 2, you just place your 4 here as a base, and then you can actually go here. You can see there is a 2 there, so you can just place it or press this 2 here. You can see that you have 4 to the exponent 2, so you are having the same as 16. So you can do that with a calculator. And then if, let's say, you are having a different exponent than 2, you don't press here, you press there. So you just say, for instance, this one here, you have 3, and then you want to actually press this one here. So you press this, it's going to give you a square there to ask you what is the exponent that you're actually having. So you press your 4, it can sit nicely, and then you can press your equal, so you have an 81. So that's how you actually end up pressing these nice things here. When you are pressing a shift or this alpha here, you are actually trying to display these things that are written on the top here. So that's what you are actually trying to do. But when you are dealing with only something that is written on a button, you just press it as it is. For instance, 12 over 10, you can just write your 12, which is the numerator, and then you can press there to get the denominator. If you're having a 10 there, then that is, you end up getting this nice thing written there. Now, what are these laws of exponents, so that we can move forward? The first one is talking about what will happen if suppose that you are having a number here, a, and then this number here is the base, it is raised to an exponent m, and then you actually multiply this by the same base, but the exponent is n. The exponent can be the same, but I want you to realize that I have this power here and I'm multiplying this power there. So what do you have to do? So this is one thing that I want you to realize. When multiplying powers of the same base, you can see that this power and that power, they are having the same base, which is a. So when multiplying powers of the same base, what do? You keep the base and then you add the exponents. That is the final results that you're supposed to end up having. And then the same thing here, if you are dividing powers of the same base, what you do, you actually keep the base and then you take the difference, or you subtract exponents. So you have that. So this one is supposed to be the same as a, keep the base, and then you take the first exponent as it is. You have your m, and then you will subtract your n. And then, of course, we will take more examples next time. But for now, I want us to actually realize these 7 laws. And then the third one is saying that, what if you wanted to take the power of a power? So you have this one here. You can see that it is a power. This is a power because it has a base and an exponent. And then now you raise it to another exponent. What are you supposed to get here? You are supposed to end up getting a. You keep this base as it is, and then you multiply the exponent. So you'll have m times n. That's what you end up getting. And then the fourth one here is actually talking about, if let's say you have a base, let me write it a little bit down there, and then you have a 4 there. I want you to copy these things so that you don't forget them. If you have a and a is raised to a negative exponent, so this one here, it is the same as you just have to have a 1 in the numerator, and then in the denominator you have the same power but with the positive exponent. And then the fifth one is saying this thing here. The fifth one is saying if you are having, let's say you are having a k here, the kth root of a. And of course, if you want to see this in a calculator, you can see that it is there, but it's somewhere up there. So you usually press a shift and then you press this here to see that you have something here. You can press OK and then press what is inside here. So this thing here, it is the same as a. You keep this as a base and then you have a 1 over the k. That's how you end up solving this nice thing there. The sixth one is actually saying that if you are having the nth, let's say you're having an nth root of some a, and then you have an exponent m there, this must be the same as you keep your a as it is, but the m that is outside should be the numerator, and then you end up having the denominator, which is n. And of course, the last one here that I want you to also realize, if you are having a raised to a 0, this one is just equal to 1. So if you are having any number here raised to 0, you must know that it must be equal to a 1, except a. You don't want your a to be equal to 0, because a to an exponent, 0 to an exponent 0, this one is undefined. So it is not defined, this one here. In maths, they usually call it an indeterminate form. What I want you to know here from now on is that having a number raised to 0, as long as this one is not 0, it must always be a 1. And then having this, you are having that, and having this one, you are having that, and having this one, you are having that, or having this one, you are having that, and when you are having this, you are having that, and when you are having this, you are having that. I hope you can actually get this. If you want us to proceed, or you want us to just take a little bit of break for today and continue next time, you can just unmute yourself, and then we call it a day. If you still want more examples, then we'll do some next time. But try and actually do this exam. Where is this? Where did I give you this? Okay, somewhere here. Try and do this homework and see what you are getting. Okay, I have to be honest with this, because some of us usually don't want to go through the process. They want to press a calculator here. So they want to press a calculator and they want to raise it to 200, and then after that they want to multiply by 5. That is not going to happen, because this number is too big for a calculator. So because it's too big for a calculator, I picked it so that you can just try and follow these rules as they are without the need of a calculator. Why am I doing that? It's because sometimes you will realize that some of the things that we need to do, you need to have an understanding, not hide behind a calculator. That is why I gave you these things, because when you're using a calculator, it might not solve 1, 2, maybe 3, but it can solve D and E. But I want you to actually use these laws that I just gave you and see what you are getting. We will stop there, but if you have a question, you can unmute yourself and ask the question. Any questions? Anyone who have a question? Okay. In the absence of questions, we can call it a day. See you next time.